Tangency, when we have an arc that is joining a point, is very straightforward. In this example here, we've got this drawing, it's at a scale of 1 to 2, so we're halving sizes, therefore this would be a radius of 1 to 5. So all I need to do here is set my compasses to that radius of 1 to 5, and then set the point of the compass where I want the arc to join. So in this case it's joining here, so put my compass point there, spin off down at the bottom, roughly where you think the centre of that arc is going to be, arc to the other point, spin it off. Where those two arcs cross down here is the centre for the radius, and that will join nicely to the drawing. We're looking at tangency when we have an arc joining a straight line. Okay, so in these three examples here, we are joining a radius of 30 millimeters to each of these straight lines. So if we take this right angle first, what we need to do here is, if our radius is 30 millimeters, then the centre of the arc has to be 30 millimeters away from each of these lines. So what we need to do is project a line at right angles to the line we want the arc to join. We then need to measure along that line 30 millimeters. So that is the radius of the arc here. If it was 40, we'd measure 40, 20, we'd measure 20, so on and so forth. And then we draw a line parallel to the line we want it to join to. Okay, then we would repeat that process from this other line. So we would go right angles or perpendicular, measure the radius of 30, and then project parallel. And where those two lines cross will be the centre for our arc of 30 millimeters. So I set my compasses to 30 millimeters. Onto the point where they cross and draw in an arc. What I need to work out now is the tangent points. So in this case, all I need to do is continue that line through and that line through, and then you'll find that when I project this line, it will join the arc at that point, and similarly down here, when I project this through, joins the arc at that point. Okay, so that was at right angles. When we've got an acute angle, or an angle at 60 degrees, then we're repeating that process we did here. So from this line, projecting out, I've already got my compasses set to 30, so what I'm going to do to save a little bit of time here is just use them to project that size onto that perpendicular line. Then, again, it's perpendicular, so it's 60 degrees this way. To get perpendicular, I need to go at 30 degrees. And then just going to use the compasses again to measure that size nice and quickly. And then I'm going parallel through those lines. Like that. And down like this. And where those lines cross, that's the centre of our arc. Set the compasses on and draw in the arc. Tangent points this time, basically, although it looks slightly different here because it's at right angles, you're going from the centre of your arc parallel to your projection line, or perpendicular to the line it's joining in at from your centre. So in this case it would be vertical, and then over here it's 30 degrees, and that gives you your tangent points that you would project your lines in at. Okay, and there. Exactly the same process for this. Perpendicular, measure your radius, project parallel, perpendicular, measure radius, project parallel, and then from the centre, draw your arc, and then project out for your tangent points. Now we're going to look at tangency when we have arcs joining arcs. So, I'll demonstrate in a second, but this is what we're going to end up looking for, where we've got an arc with a radius of 40 joining here, and an arc with a radius of 75 joining here. Now, when you're looking at this, what you need to consider is, how do these circles relate to each other? Okay, you can see a full circle here and a full circle here, and then an arc is just part of a circle. So, if we picture this, what we have is, if you drew the whole circle here, you would find that this radius of 40 sits here. Okay, so this circle is outside these circles. When you do the same for the arc with a radius of 75, you find this. So these circles sit inside this circle. So for calculating the distances that you need to use here, we need to think about this. So let's say we've got a circle here that has a radius of 70 millimeters, and this one has a radius of 35 millimeters. The distance between these the arcs, or the centers of the circles, is this. I'm going to color coordinate this again. So if we draw the radius for the 70, and then the radius for the 35, you can see there the distance is the two radii added together. So the distance between, let's call this centre A and centre B, would be 70 plus 35, giving a total of 105 millimeters. In this one, we have to think about it slightly differently. And by slightly, you're subtracting. So if this is, again, a radius of 70, but this time the smaller circle has a radius of 30, then what we need to think about is this. The distance between these two is this. If I draw through the centres the radius of 70, the radius of 30 sits its radius back along that line. So if I draw that parallel there, it would look like that. So, in this instance, to work out the distance between these two radii, we are doing 70 minus 30 to give a distance of 40 millimeters. So basically, if the circles are sitting outside each other, you add them together. If they would sit inside one another, or one is inside the other, then you are subtracting the radii. So to work out where the centre for our radius of 40 is, we need to look at the sizes we've been given. These are diameters, so we're going to half them. So the distance from the centre of the diameter of 30 would be 40 plus 15 to give 55, and then 40 plus 25 to give 65. So, set my compasses to 55. Put that in the centre of the radius of 30 and spin it off. The centre is going to be somewhere up here. And then I set my compasses to 65 from the diameter of 50. Where they cross is my centre, set this back to 40, set it on my centre, spin it round. Tangent points, simply go from the centre of your new arc to the centre of the one that was there, project through, there's your tangent point. Similarly here, that's your tangent point there. So now if we look at the radius of 75, thinking back to what we sketched over the top of the solution here, the radius of 75 sits on top of these, or these are inside it. So like I say, this time we are doing a subtraction. So we're doing 75 minus 25 from here, which would give us 50, and then 75 minus 15, which is 60. So set our compasses accordingly. So let's go for the 50 first. Spin it off, and then the 60 from over here. With A cross is the radius, the centre of our radius of 75 arc, and sitting on that centre, spinning it round. And then again, to get our tangent points, we're going from that centre through the centre of the circle that already existed. That's your centre point there. And then, sorry, your tangent point, and then we're going for the same over here. So then when you firm in, you would just firm to your tangent points. In this example, if we look back at the solution, what we're seeing here is it's a mix. So we've got this larger arc here, which has the radius of 60. And if we were to finish that off, you can see that, and it's going to go off the page here, but I'll draw it over the top anyway, that it is this diameter of 60 is inside the radius of 60, the diameter of 32 is outside. So we would subtract here and add here. For this circle, you can see that so this is a radius of 50. You can see that the diameter of 60 would sit outside the radius of 50, so we would add 30 and 50, and the diameter of 32 is inside, so we would subtract 16 from 50. So when we're thinking about arcs, all you need to remember is if they sit outside each other, we are adding, and if one sits inside the other one, then we're subtracting the radii. To create an arc that joins a point in Inventor or electronically, you would do this. So you would complete your sketch to a point until all you need to do is put the arc in, and then it's simply a case of choosing the arc tool, clicking the start point, clicking the end point, and moving it to either roughly the size you want, or while you've got the box there, you can type in 250mm, press enter, and that is tangency, where it's an arc joining a point completed electronically. To produce an arc that joins two lines electronically, much more straightforward. All you need to do is produce the lines that you want the arc to join. Use the circle tool. In Inventor, you know that it always wants the diameter rather than the radius. So in this case, if it was radius 30, we would need to do a diameter of 60. Then all we need to do is find the tangent constraint, which is up here. We then click the circle and click the line we want the tangent to, click the circle, click the line. You can see here it doesn't quite join in yet, so what you can do is use the extend tool to extend the line to join the arc, and then use the trim tool to remove the excess arc. That automatically creates the tangent point. So similarly here, if we were to draw our diameter of 60, then use the tangent tool to join the arc to the circle. All not quite joining, overshooting the mark, so trim the line to the tangent point there, extend the line to the tangent point there, and then trim the extra arc. Another method that you can use to create a tangent between two straight lines is to think of it simply as a tangent being a fillet. So if you know the sizes of the lines that it needs to be, when you know what your radius for your tangent is, just use the fillet tool, set that to your radius, and then click the lines, and that will automatically create it, perhaps a lot quicker than doing it in the other method. To produce an arc that joins another arc, again, very straightforward. All we need to do is draw the circle roughly where you think the centre is going to be. In this case, we have a radius of 40, so it's radius 40, diameter 80. We then just use the tangent tool again to click the circles that we want it to be a tangent to, and then again use the trim tool to remove the excess circle. So similarly, for a radius of 75, it should be 150, tangent tool, and then trim the excess. So for this one, we've got our radius of 60, diameter 120, roughly in that position, tangent and tangent, trim the excess, and then we have the diameter of 100, tangent and tangent, and then trim the excess.